gives us an expression for our terms. That's pretty simple and easy to follow. But what do we want? What are the other parameters that we often want to solve for, or that we solved for last time? If we actually want to solve an initial system, right? We have our mass, we have our stiffness. What are the two bounds to our
initial velocity?
Yeah, initial displacement and initial velocity, right? So those are the bounds to our equation of motion. So that would be a good next step for this, right? We have an equation, but we need to know what our initial conditions are. Right, so let's solve. Let's solve for our initial conditions. That's x naught and v naught. Right, so again, we have x of t is equal to a1 cosine of omega nt plus a2 sine of omega nt, right? So we want to get our velocity for this equation. So let's take the derivative of that. And what's our first term going to be? What's the derivative of cosine?
Minus a1 sine.
But we have something multiplying our t, so we have to pull this out.
Minus a omega n.
Yeah. If you said that and I didn't hear you, I'm sorry. So I've got negative a omega n sine of omega nt. How about that? And then what's the derivative of sine?
Cosine. So
Cosine, and what else do we have to change?
t goes out there.
Yeah. Not the t, the omega n.
Negative.
Yeah. So a2 omega n cosine of omega n t. That's 1. That make sense? That's pretty easy. Let's set t equals to 0 for our first equation, right? That gets us x of 0 is equal to x naught. What is the sine of 0? 0, right? Big old 0, so that just goes away. What's the cosine of 0? 1, so it's just going to be x naught equals a1. Super awesome. And then do the same for velocity. No, so x naught, velocity 0 is equal to v naught, right? So what is the sine of 0? 0. So this whole thing goes away. And what's the cosine? Right? 1. So what are we left with? A2. Yeah, A2 omega n, right? So that gives us an expression for A1 and A2, which leads to this very short and very beautiful equation. As they say, x of t go to x naught cosine of omega nt plus v naught over omega n sine of omega nt. How cool is that? On the list of cool things you've seen today, pretty high up. Probably definitely within the week. Yeah, I mean that's to me that's really cool. Granted, I get paid to teach vibrations, but So this is a really nice general form to our solution, right? So it's short, it's descriptive, and it's generalized. So it's very helpful when we start to talk about damping, right? So here you're like, that's a lot of math for a sinusoid. And it is, but it's helpful as it expands better, or it scales better than the other equations.